Hello students, I am Ashish De. I am taking one of your subject, that is digital communication. In my earlier class, I have given a PDF note on line coding. Okay, now in today's class, I want to teach inter-symbol interference. So what is inter-symbol interference, or in abbreviation form it is ISI. Now from the term interference, what do we know about interference? Interference means we are taking interference means when two signals are incorporated, then there is a mixture of both the signals, that is called interference. In a communication system, when the data is being transmitted in the form of pulses or bits, the output produced at the receiver due to other bits or symbols interferes with the output produced by the desired bits. Okay, suppose there is a bit of data transmitted here, here is also another bit of data, then these two bits interfere each other. Okay, that causes the interference, and this is known as inter-symbol interference. Okay, so in case of digital communication, only bit are transmitted in form of data. Data are transmitted in form of binary pulses or bits. Okay, so if one bit of symbol interfere other bits of symbol, then that is called inter-symbol interference. The inter-symbol interference will introduce error in the detected signal. Okay, the inter-symbol interference ISI arises due to the imperfection in the overall frequency response of the system. When a short pulse of duration TB, suppose the duration is TB, suppose this is the short pulse of duration TB seconds is transmitted through a band limited system, then the frequency component content in the input pulse are differentially attenuated and, more importantly, differentially delayed by the system. Due to this, the pulse appearing at the output of the system will be dispersed over an interval which is longer than TB second. Due to this dispersion, the symbols TB will interface. Due to this dispersion, the symbols each of duration TB will interfere with each other when transmitted over the communication channel. This will result in the inter-symbol interference. The transmitted pulse of duration TB seconds and the dispersed pulse of duration more than TB seconds. Okay, so if this is a transmission system, if this is the transmitted system, and here one bit is transmitted as a symbol of the bit is of duration TB. Okay, so this bit is transmitted. Okay, so we are getting a dispersed output, that is that has the duration greater than TB. Okay, so this is basically, this duration is basically greater than TB. Okay, so this is the effect of inter-symbol interference. Now, what are the effect of inter-symbol interference? In the absence of ISI and noise, the transmitted bit can be decoded correctly at the receiver. The presence of ISI will introduce error in the decision at the receiver output. Hence, the receiver can make an error in deciding whether it has received a logic 1 or a logic 0. Now, what are the remedies to reduce ISI? It has been proved that the function which produces a zero intersymbol interference is a sinc function. Hence, instead of a rectangular pulse, if we transmit a sinc pulse is look like this. So if we instead of rectangular pulse, if we transmit a sinc pulse, then the ISI can be reduced to 0. Okay, so sinc pulse is better choice for transmitting the bit. Okay, so this is known as Nyquist pulse shaping. The sinc pulse transmitted to have a 0 ISI. Okay, further we know that Fourier transform of a sinc pulse is a rectangular function. Hence, to preserve all the frequency components, the frequency response of the filter must be exactly flat in the passband and 0 in the attenuation band. So if you transmit a sinc pulse, the frequency response of the filter looks like this. The flat curve in the passband and a 0 attenuation in the stop band. Okay, so this is the ideal frequency response curve, that is H j omega. Okay, and here is the frequency. Suppose here is the omega. Okay, so it is the ideal characteristic curve when the intersymbol interference or ISI is practically 0 if we transmit a sinc function. So to avoid intersymbol interference, we have to transmit a sinc function in the transmitter. Okay, so from this video what we learn, what is intersymbol interference? Okay, when in digital communication we are basically transmitting some binary pulses in form of binary bits. Okay, so if one bit interfere with other bit, then it is known as intersymbol interference. Okay, now intersymbol interference actually in a transmission system actually increases its duration, bit duration. Okay, so this is the result. Okay, now to avoid this intersymbol interference or ISI, we have to transmit the data with a sinc function. Okay, as if we transmit the data with a sinc function, then the frequency response will be an ideal one. Okay, so there will be a 0 ISI.